Good morning, and welcome to Summer 2017 webinar series, Performance Monitoring Easy as Pie. I will be your presenter for this morning. My name is Gans Guzman, and also in the room I have Sterling Brockwell, who worked on the Python scripts for collecting the data and also configuring the Pi. And we'll look at those later on in this discussion. The agenda for today, we're going to discuss differences in the Pi platform. We're also going to look at preparing the Pi. We're going to look at visualizing the data that gets collected on the Pis, and then we'll also discuss deployment options. So not all Pis are created the same, right? When we looked at the Pis initially, and this was a while back, we found that even though they all had 100 meg interfaces, they could not all achieve 100 megs in both directions, right? This was done actually with iPerf. We also tested the Banana Pi Pro, which of course has a gigabit interface, so we were able to achieve higher data rates. Just know that for the purposes of this performance monitoring, the interface throughput is not an issue. But we wanted to present this data because if you decide to do some other tests, which we will talk about at the end, this will actually come into play. So along the same lines, right, the initial Pis that were released did not have wireless capability, but you could put a wireless USB dongle into it and actually have wireless. But as of the Pi 3, they actually built wireless into the board. Also with the Banana Pi Pro, which is an older board, it did have wireless as well. And then the newest Pi, which is the Raspberry Pi Zero W, that also has built-in wireless. Just know that wireless on all these boards is 2.4 gigahertz. So the throughputs that you're going to be able to achieve over wireless are going to be different. Now that said, you could install a 5 gig wireless USB dongle into the device and get it to work properly. And we have done this in practice, and we currently have a couple that run with them today. They have AC wireless dongles in them. But just know, once again, this is more about your users and where your users live than it is necessarily about the throughput through the device. So, preparing the Pi. We always suggest that you just go ahead and follow whatever practices are laid out by Raspbian or the Raspberry Pi organization, because at the end of the day, these will probably change, and we don't want to have to worry about documenting these changes. But we will discuss what we do, or the capabilities of the script that we have put together to actually configure the Pi once it has a base OS on it. Now I will say that right now there are two Raspbian images. One is a full desktop image, one is a light image. I recommend installing the light image for this particular project, only because we want to keep the load on this device as small as possible. Okay, so as I said, there's a script that we can provide you that will update the OS on the Pi. We'll install InfluxDB and its dependencies, which we need in order to store the data that we're going to be collecting. It will set the time zone to Eastern Standard Time. It will change the keyboard layout, and after changing the keyboard layout, it will prompt you to change your password. Why is this important? Well, the keyboard layout by default is GB, which maps some of the special characters to different keys. So if you were to change your password prior to changing the keyboard layout, it would actually cause you an issue with your password once you did change the keyboard layout, because some of the special characters would not match. So we decided to go ahead and try to avoid this problem by doing all these changes with the script and then prompting you to change your password prior to rebooting the device. So then the second script we provide is smartdb.py. This script actually will create the database and then prompt you for the websites you want to monitor and then start the monitoring process. If you stop this script, which you can, Control C will stop the script, and you run it a second time, it will basically read the PI, see what databases are on there, ask you if you want to continue to use that database, and if so, you would type it in, or if you want to create a new database, you would type it in. Then it would basically pull up all the sites you were monitoring previously and ask you if you wanted to continue monitoring these sites. Or do you want to append to the site, or do you just basically want to blow away the site or the list and start with a new list? And then, of course, start the monitoring process again. Just know we are working on decoupling the process, the start of the monitoring process from the script, so that you could actually just start the process with what's already currently configured. So let's talk about securing your PI, right? I am a proponent of securing your PIs. Reason being that it's a device that's on your network, and if it doesn't have a firewall to block or restrict access to the ports that are open, it's a device on your network that could be compromised, right? So by default, the only two ports you're really going to need on this PI accessible are going to be port 22 for SSH and port 8086. And the port 8086 is only there for visualizing the data that's on the PI. As you can see in this example, I've locked it down to specific networks. If you choose not to lock it down to a specific source, you can basically put no source in there, of course, and then it just allows it from anywhere. But I recommend that you lock these down to at least your management network. But it's really up to you as to whether or not you want to follow these guidelines. But here's an example of an IP table configuration that will work. Once you have this IP tables built, so you've entered these commands, you've built the IP tables, the PIs themselves, or at least the Raspbian image that's on the PIs, does not have a concept of persistency. So you actually have to install a couple extra packages in order to get that function in the PIs. So here are the commands for installing the packages that you're going to need. And then once you install these packages, it's going to prompt you to save the current IP tables config to a location. Once you've done that, any changes that you make in the future will have to be saved manually. So you'll have to run this command, iptables-save, in order to be able to save your changes that you make to the IP tables. Also, you could edit the files directly that get created, and then restart the PI, because there is no command. Well, there is a command to reload the table, but I found that it doesn't seem to work the way I would expect it to, so rebooting the PI is really your only option. But just know that it will reread that cached file and then apply those changes. Okay, so now we move on to visualization. The visualization software will actually be installed on another machine, some Linux box. I will tell you that we have tested this. Well, Grafana has images for pretty much anything. I mean, I've seen them for Linux, for Mac OS, for Windows. We recommend using the image or using it on Linux. And this script here that we provide installs Grafana and its dependencies on the box. Just know that the script today in its current form only works for Ubuntu, and it doesn't even work for Ubuntu 17 because there's some change from 16 to 17. So just be aware of that. We are working on making changes to the script to make it more intelligent, but for now, just know that it only works on Ubuntu 16. The second script, which is actually, I think, the better of the two, not just in what it does. The second script actually will configure your Grafana instance based on some prompts. Why is this important? Well, we found initially when we did the first rollout of this project that folks were having problems configuring Grafana to get the data or to visualize the data that was being collected by the Pi. So in order to avoid those hurdles, we went ahead and we developed a script to make these changes to the Grafana instance so that it will start visualizing the data. Now, of course, once this initial script runs, you can go in there and modify it and make changes to it. But just know that this script is actually going to prompt you for the IP address of the Pi. Once you put that in, it will log into the Pi essentially. Well, let me take that back. It will query the Pi, figure out what databases are running on the Pi, and ask you which database you want to use. And then based on the data in the database, it will build out a dashboard, but it will also prompt you for the name of the dashboard. So one caveat that I probably should have mentioned earlier is if you're deploying a lot of Pis, you're going to want to name the databases uniquely for each Pi. And I would almost recommend you name it based on whatever host name you put on the Pi. So I would recommend that each Pi would have a different host name as well. The reason being is when you run this configure Grafana script, it will create the data source that's required in Grafana for it to be able to talk to the Pi. And if the databases are all named the same, it will overwrite your data source. So you're going to want to make sure your data sources are unique. And since the data source is based on the name of the database, you're going to want them all to be unique. Okay. But like I said, this will build out the dashboard for you. And here is an example of what that dashboard would look like. But let's go ahead and go into a live system and actually take a look. There we go. Okay, so here is a live Grafana instance. It is monitoring 2 or 3 Pis currently, or visualizing the data from 2 or 3 Pis. I currently have something like 8 or 10 nodes that are actually collecting data. But we're just going to look at these that I have here. So here is 1 Pi that's currently being monitored. And I will tell you that this is actually running the newest script. The one I'm going to show you in a second is running the older script, so you're going to see some differences. But as I said, when you run that script, it builds out these graphs for you. And it basically names a graph by the name of the site that you're monitoring, right? And it also gives you these data points. So it's looking at how long it takes to actually do a DNS resolution. How long does it take to do that TCP connection? If there's any SSL involved, how long did it take to negotiate that SSL connection? Prefetch, if it's pulling any files before actually downloading. Are there any redirects at the site? And you will see that if you actually go to google.com instead of www.google.com, it will actually redirect to www.google.com. So you would see something in this redirect. And then the start of the transfer, and then the total time to actually download that page. Okay. Now, something that we had with the old version of this monitoring script that monitoring project that we had done, we had a limitation of only being able to do 10 sites per Pi. Well, with the Python script, we were able to overcome that limitation. So we can definitely squeeze in a lot more than just 10 into the monitoring. So here is the other one, and as you can see, the naming is a little bit different. Reason being is the way we actually put the URLs into the script was a little bit different, and we went in and changed it because it made more sense to actually tell it whether or not it was an HTTP site or an HTTPS site. So it would avoid some of those redirects if possible. But you can see you're getting the exact same data here. And once again, it pulls in all the sites. And they were different on this Pi. So you know, every site that you monitor may not have the same software requirements. So the sites may be different from site to site. But at the end of the day, you want to make sure that somewhere there is a comparison for the sites that you are gathering. And then I went ahead and created some site aggregate graphs. Now these don't get created automatically. These have to be created manually, but it's not difficult to do, and I'll show you exactly how I did it. So here's Pi 6, here's Pi 8. As you can see, the sites are different on each of them. This one has more on it, this one has less, but there are some correlations. So I could actually see that Facebook here and Facebook here have slightly different metrics. Okay, I could see that my min was 609 milliseconds, but here the min was 0 nanoseconds. Now I'm going to say that probably has to do with this little point right here. So it looks like for whatever reason there was a dropout here, and if I actually went back and looked at 6, so let's do that real quick. I'll make it the same time. That other one. You can see that all the mins are the same. So that tells me that something happened in that Pi that dropped it out for that time on all of them. So that's good to know that it wasn't an issue with Facebook, but it was more of an issue with the Pi itself, or maybe something in the network that caused that Pi to drop out at that site for that polling period. So, but let's go ahead and we'll ignore that first column for now, knowing that we know that this data is bad because of that point right there. But look at the average times. So the average here is 647, and the average here is 754. So that could tell you a couple things. Let's say this was the core of your network, and this was a site across the WAN. So there's a little extra latency on the WAN side, but it's about 100 milliseconds. Is that average? Are you always seeing about 100 milliseconds of latency across your WAN? If you are, that's probably a bad thing. This should probably be closer to maybe 10 milliseconds at best. But you would hope they would be even better than that. So, like I said, data points to be able to correlate, but at the end of the day, I would want to correlate this with smoke ping, right? So that I could see that, yes, there was latency during that time of day, which caused that average, or really caused this spike here maybe, that caused that average to be so high, all right? And this is, I put this one up here for comparison. This is kind of what it used to look like. All we could get was total time with the way we were doing this before, using collectd to actually run the metrics. We couldn't actually break it out into those individual parts of the curl lib that we could get out of the data. So let's go ahead and discuss deployment options. So as I was saying earlier, right, it would make sense to deploy these one at each site, and maybe even two at each site if you want to be able to do one wired and one wireless, and then one in the core closest to your internet connection, right? So that way you could see those differences, as I was saying, across the WAN, right? And if you see a difference in a particular site, then you're going to need to correlate that data, right? And I mentioned smoke ping for latency, but you also want to do cacti for utilization, so that way, if there was an increase in utilization, that could explain why things were looking the way they were. Without those data points, you're basically just guessing at what's going on. And as I said, a wireless one, you could deploy a wireless one in the classroom where someone's complaining about performance issues, right? And then you could also use other tools to see if something is going on in the network, right? So let's say someone's complaining about a particular site, and let's say maybe you forgot to monitor that site at your core location. Well, from the pies, you can actually run the curl commands, all right? And this is essentially the command that we're running that's giving us the data points that you saw being visualized in Grafana. So you could actually run this from the command line, from the pies, and get these numbers. So you could actually do a sort of point in time comparison of what's going on with that site. And as I said, lookup, is the time that it takes to do a resolve, the initial TCP connection, all right? So it's got to do that handshake. Whether or not there was any SSL involved, the prefetch, the redirect, right? In this case, because I didn't do the www.google.com, it had a redirect in there. The start of the transfer and then the total transfer time, or the total download time. Also, another tool that's useful to use, and this can be run from the pies as well, is MTR. MTR actually will give you the number of hops between you and that endpoint that you're going to. And if this changed for some reason, let's say you ran this a month ago and there was 5 hops, and then someone's reporting a problem and you run it again, now there's 10 hops, right? The hops outside your network, there's not much you can do about those, right? But I would be concentrating on the hops inside your network. So let's say you're running this from school, and you should have a single hop from school to core, essentially. Unless, of course, you've got some sort of hybrid configuration. Like I've seen some sites where they actually have multiple providers to provide their WAN. They'll have like most of their sites being provided by CenturyLink, and then there's a couple of outliers that are being provided by AT&T or Time Warner, right? So you're going to expect to see possibly, depending on how it's configured, some extra hops in there, right? But if like I said, if you ran it one time and you saw 2 hops, and then you run it a month later and you see 3 hops, well, something changed, right? Well, why did it change? And then this is data that you can provide to your WAN provider when you're troubleshooting this issue to say, why did this change? Is there a reason why this is the way it is today? Okay. Also, you can run iPerf from the pies. Now, as I said, the limitation of iPerf is based on the pies themselves. I would never run iPerf on a W0 or a 0W. But from a wired connection, you can definitely run iPerf and see if there's an issue with packet loss when you're transferring data. So just know there's a limitation of 100 megs on the pies. So this particular example here, you may not want to make this a gig. You may want to make sure that this is 100 megs. And then the bidirectional test. Whenever I run the bidirectional test, so the bidirectional test will run one direction and the other if you do a recursive. If you do a bidirectional test, it actually does them both at the same time, which sometimes I've seen that that test data be a little bit skewed. So I prefer to run a recursive test so that you actually will do an upload first, complete the upload, then do a download. That way the numbers tended to be more true as far as the performance of that link. But a bidirectional test can be run, and then you can compare the two to see whether or not you see any differences. But I historically have always found that there is some differences, so I tend to run recursive tests. So that is all I have for this presentation. If there are any questions, we will go ahead and answer them now. Just know that these scripts will be made available upon demand. We will not post them only because we're currently making changes to them, and we don't want to really be tracking revisions of these scripts that are out there. So we would prefer that you come to us. So you could either send myself an email or send an email to Sterling, or send email to cne@mcmc.org, and we will get these scripts to you. So the first question is, do you guys use this yourself? Currently, we do not use this in production. This is more or less, I've done 2 pilots based on the old configuration. I have not done any pilots on the new configuration, and I've actually helped 4 or 5 sites deploy this in their network. with the old configuration. And so far, it has been useful. Once I was able to troubleshoot an issue with SchoolWire, and then the 2 pilots that I did, we actually found issues in their network that were on the WAN. So I mean, I believe the tools are useful, but at the end of the day, it's you guys, the community, who are going to determine whether or not this tool is useful for you. How long does it take to deploy the scripts? No time at all. I mean, the scripts are self-contained. The only thing that, like I was saying, the install script for the Grafana is OS specific. So there are some changes or some things that need to be done beforehand before you can run the actual Grafana creation script. So be aware of that. And if you, like I said, if you contact us, we will work with you to make sure that things work the way they're supposed to. I myself have tested this on CentOS, I've tested it on Debian 9, and I've tested it on Ubuntu 17, and pretty much I have a kind of framework in order to get the pieces in place to be able to run the actual the Grafana script to actually populate the dashboards and the data sources and all that stuff. How do you provide support and update for the scripts? Well, that is still yet to be determined, right? I mean, at the end of the day, if a script is working, we're not necessarily going to provide an update. We may create enhancements to the script, and if we do that, we will keep track of the people that we give these scripts to, so that we can provide them some feedback, you know, so that we can provide them new scripts and they can go ahead and kick the tires on them. Are trial customers still using the Pis? Yes, as far as I know they are. I have actually worked with some to deploy them on VMs, so Linux VMs, because, you know, yes, Pis are inexpensive, 35 bucks. If you go with a Zero, it's like $10. They're inexpensive, but some folks, you know, for whatever reason, cannot get the funding to do this. So, as I said, I've worked with them to deploy these tools on virtual Linux boxes. They have them out at their sites already. They already have VMs out at their sites anyway, so it's just basically just dropping a Linux VM on their VM server and getting it up and running. So, and if that's an option that interests you, reach out and we will help you do that. Let's see. Are there any more questions? Nope. Okay. Well, sorry. Here's one more. How about security? Do you use SSL to send data to the database? Well, it's not necessary because the database is local to the Pi. So communication between the metrics collection tool, or the metrics collection, and the actual tool that runs the test to gather the metrics are on the same box. So the communication is enclosed within that device. So there isn't any need for SSL. Now, you can configure Grafana for SSL. I have not done it yet, but it can be done. I've seen the bits in there. So you could actually SSL enable the visualization piece of it. But once again, if it's on your network, I mean, is it a big deal? I don't know. I mean, whatever your security posture is, you know, definitely do whatever it is that is in your security documentation or process. I won't tell you that you shouldn't enable SSL. I mean, it can be done. I just have not done it. Okay. Okay, so that's it for questions. I want to thank everyone for sitting in on this webinar. Just know that we will help you to deploy this process. I think that the data that we can collect is valuable, and really it's up to you guys to tell us what improvements we can make to this these scripts, and also what improvements we can make as to the data that we're collecting. But thank you.